This video is going to talk about the signal flow within a studio's analog desk and a live analog desk. To start, here is a quick summary about the signal flow in a studio's analog desk. The desk I am using for this summary is the MTA 990 desk that can be found in Eastlake 2 at Perth College UHI. To first get the signal, we need a sound source to record, so I have set up this radio in the live room with a Sontronics Orpheus condenser microphone, which I have positioned correctly near the sound source. Then, with a balanced XLR cable, the microphone is then connected to channel 1 on this wall box, which is located in the live room. Once it's entered the desk, the signal is amplified by the channel's preamp from mic level to line level, before continuing into the routing matrix, which is used to decide which output the signal should be sent to after it is passed through the channel strip. Since we are using a condenser microphone, we will need to apply phantom power, which is the plus 48 volts button on the desk. Since the microphone has been plugged into channel 1, I will be pressing the channel 1 and 2 button. I will then go on to the gain pot below and add on some gain until the VU meters display a good representation of the signal level. This is important because the VU metering is used to measure power levels of audio frequency signals. After doing that, I will proceed to push up the channel path fader. This will allow me to check to see if my Pro Tools session is getting a signal. After passing through all this, it then moves on to the EQ section and then further down into the auxiliary section, which is where the signal can be sent to certain places. This can be done with the help of the patch bay. After this, the signal then moves through to the channel pan section, which has a PFL button which allows you to monitor the channel signal level at a point immediately prior to the channel fader. There is also an AFL button, which is similar to the PFL, but takes its signal from a point immediately after the channel fader, showing the level of the channel's contribution to the mix. I will then pan the channel to the left since we are using channel 1. And then finally we move on to the monitor path fader, which is used to decide how much of the signal is to be sent through to Pro Tools from the output. Before pushing the fader up, I move to the other side of the desk, where I proceed to turn off the master mute and auto mute so that I will be able to hear the audio being played through the speakers. I will then move onto the group bus master faders and push up the blue and red fader till they are at 0 dB. Finally, I push up the monitor fader. This fader will need to be moved to 0 dB so that the best signal will be sent to Pro Tools. Once pushed up, I should be able to hear my audio. Now that my signal is coming through the desk smoothly, I will now demonstrate how to work the auxiliary sends so that I can use these headphones through the desk. First, I used a Q-amp box cable and plugged that into the Q1 XLR connection that is located on a wall box that is in the studio room. This is where the patch bay comes into use. On the patch bay, I will need to plug 2 Bantam cables into aux sends 7 and 8 and then into Q-amp input left and right. After that, I will need to unmute aux 7 and 8 on the desk and add a bit of gain. And then finally, I will need to go to the other side of the desk so that I can unmute aux master 7 and 8, adding some gain onto both of them as well. After doing that, you should be able to hear the audio coming from the headphones. When it comes to an analog studio setting, you should take the RT60 into consideration. The RT60 is the time it takes for reflections of a different sound to decay by 60 dB. In a studio like this, the RT60 should probably be between 0.2 and 0.5 seconds. In order to ensure that you are within the correct RT60 time, you can apply a variety of different treatments to a studio. Some examples of this can be something as simple as setting up bass traps, which function by turning sound energy into heat through friction, so this would deal with any problem frequencies. In general, you could just set up some absorption materials on the walls, materials such as foam panel. And that was a short summary on the signal flow of a studio analog desk. Here is a quick summary of the signal flow in a live analog desk. The desk I am using for this summary is a Soundcraft MH2. The sound source I am going to be using for this summary will be music from a mobile phone. To summarise quickly, the signal will enter the desk through the connected input, which is behind the desk at the back. It will then go through the preamplifier, which is situated at the top of the channel strip. After that, it will then pass through the equalisation section. On this desk, this is a semi-parametric EQ. Then the signal moves on to the auxiliary sends section, which is used to send a copy of the signal to effects such as reverb. After that, the signal then passes through the channel pan pot, which is where you can pan either left or right so that the audio can come out of both left and right speakers equally. Then finally, the signal gets to the channel fader, which determines the amount of signal that should be sent to the front of house monitors through the stereo left and right output. These faders have LED meters next to them so that they can meter the amount of signal that is sent to the stereo output. Now I will demonstrate how to properly create the signal path. First, I will need to connect my sound source to the desk, and I will do so by connecting the phone to two left and right jack-to-jack cables, which will then be plugged into the line inputs 1 and 2. I will then connect the left and right speakers by plugging in two XLR cables into mix 3 and 4, which are located at the back of the desk. After that, I will go to the top of the channel strip and select channels 1 and 2's line buttons so that they will connect with the jack cables. Then I will move to the pan pot, where I will pan the channels left and right in order to have the signal come out of the left and right speaker. After that, I will then push up the channel faders till they reach 0 dB. And then finally, I will push up the master faders, which will allow the audio signal to come out of the speakers. I will now demonstrate how to operate the auxiliary sends so that I can insert a compressor and reverb. For the compressor, I will need to plug in two jack cables into the channel inserts send and return, which are located at the back of the desk. Then I will move to the back of the effects rack, which contains outboard equipment such as reverb, compressor and delay. It is here where I will plug two corresponding jacks into the compressor channel 1 input and output. This will send signal into the compressor from the desk and then return it. In order to use reverb, we will need to once again use the effects rack. First, we will need to send signal to the rack by using an XLR cable and plugging that into auxiliary sends. Then I will connect an unbalanced jack cable into the input reverb unit. After that, I will then use two jack cables and plug them into the left and right output on the reverb unit. Then I will use two more unbalanced jacks to plug into the left and right line input on the stereo channel, which is the 4 blue faders. After that, I will then move onto the desk and turn the channel 1 and 2 auxiliary knobs. Then finally, I will push up the aux fader, which will apply the reverb, and then the stereo channel fader, which should let us listen to the audio, which now has reverb applied. And that was a quick summary on the signal flow within a live analog desk. Some pointers though for when using this desk are to always monitor your signals on the desk. This can be done through the LED metering. Another thing to know is that the live desk also has AFL and PFL buttons as well. The purpose of these is similar to the studio desk, but the only difference is that the PFL is disguised as a solo button which can be operated simply just by pressing it. The RT60 time for live should also be considered. Here are some text below on some more information on that. And one more thing to remember for live is the SPL regulations. Here is some text explaining some more about that. Now, when comparing both desks, it's obvious to see that they are both slightly similar in design, but some of the main differences that you can point out is that even though they have the same layout, the live desk has no patch bay. Another thing is that a studio Analogue has group buses, but a live does not. And finally, a live desk has 3 outputs, which is the centre, left and right. Now, one more thing I would like to add is about the history and further developments for these 2 desks. Here is some text below that will explain more about that. This was my guide talking about the signal flow within a studio's Analogue desk and a live Analogue desk. My name is Lucy Burns and thank you for watching.